46 was your first one. Okay, let's take a look at this. 46. Z sub 1 equals 50 cosine 80 degrees plus I sine 80 degrees. And Z2 is 10 cosine 20 degrees plus I sine 20 degrees. And the instructions were to divide. Find Z1 over Z2?
Yeah.
Okay. So Z1 over Z2 for division, you divide the numbers. 50 over 10. Going to abbreviate to cis. And you subtract the angles. 80 minus 20. Here, I'll show the step. And I'll do so in a darker marker.
So it's 5 cis 20?
No, 5 cis. Yep, 80 minus 20. 80 degrees minus 20 degrees. So the answer is simply 5 cis 60. Compare this method of the division to the one we went over yesterday with finding the complex conjugate.
Is that when you multiply it by 1?
Now, when you multiply, yeah, top and bottom by 1.
That's a problem.
But you multiply
now,
it by the opposite of the
complex conjugate of the denominator.
Yeah.
Which is a fun term. Incidentally, this is a totally fair non-calculator conversion problem because you should know the cosine of 60 is root 3 over 2. So this is 5 root 3 over 2 plus the sine of... No, the cosine of 60 is 1/2. You guys should have been correcting me a lot faster on that.
We
Okay,
didn't correct
recording,
it
so
all.
walk around backwards. Walk around backwards, walk around behind. Yeah, that's fine. So that should be 5/2 plus 5 root 3 over 2 I. Do I have the cosine and the sine correct for 60 degrees?
Yeah.
Okay. So this is a very fair one. I know they're both positive because 60 degrees is in quadrant 1. All right, Janae, you had a question?
I don't really know the difference between the polar and rectangular of the equations.
We haven't done any equations yet. We're just doing
No, I mean
numbers.
with the operation.
The operations. Polar division, we went over yesterday, was you divide the numbers.
No, I'm saying when it says like convert to polar,
Oh.
I don't know how to like.
Convert.
I don't know what polar looks like.
5 cis 60.
Okay, so what's the other one?
Rectangular.
And that's what one that is.
Yep, this is polar right here, and this is rectangular.
But they were asking for the polar one.
Yeah, the polar
so
answer.
we didn't have to do
No,
it.
you didn't have to do that. I just thought this is a great one, to example of one you should know, like, almost off the top of your head by the time we have the test on Tuesday. You should be looking at 5 cis 60 and going, oh, quadrant 1, I should know that. Yeah.
That's why I said by.
This is all we're doing. You're learning the last new thing today in a couple minutes for it, and then nothing but review for 2.5 days. Just polar imaginary, polar complex numbers. That's all it's on. So that was 44. Do I have another question from last night's homework?
50? No, 50.
52, 50 and 52. I should have time to do both.
I think you should do 50 first.
I will do 50 first. Okay. And that is Z1. I'm going to start using my abbreviation. Z1 would be apparently 1 cis 70. Z2 would be 1 cis 230. And what was it? This is still in the division section. Find the quotient. Correct?
Uh-huh.
We're still dividing?
Is that
Yeah.
what it means to divide?
Yes. All right, find the quotient is to divide.
Mr. B, how is she going to film over that way if I'm sitting in front of her?
You're fine. She'll tell me if you're in the way. Okay.
Like,
So guys, this is 1 over 1, and then 70, so that's just going to be 1. 70 minus 230 is negative 160. Is that correct?
Yeah. Then
Okay.
Don't you need to change it?
I'd like you to change it, yeah. I have trouble figuring out immediately where that is, so I'd
Yes,
rather say
200.
1 cis 220. Is that correct?
I got
200.
200. Wow. I'm not having a
360
good
minus
mental math day.
160. Wow. Yeah, you aren't.
200.
It's okay, Mr. B.
Thank you. I appreciate that. That's not one I would expect you to be able to convert to rectangular, without a calculator. Because 200 degrees doesn't give you a reference angle of 30, 45, or 60. It gives you a reference angle of 20. But that's all you do. That's all you do. That's and now 51.
cosine of 200
52.
is 0.48.
52, thank you. 52 you have to convert. You have to convert to polar first and then divide. Or you could do the complex conjugate thing. Well, it's actually 2 points. All it says is leave your answer in polar form.
Yeah, so wouldn't you just convert it?
So I would convert it because that's a lot easier. Your other choice, though, which you do have available to you, is to do it the old way with the complex conjugate and then convert your answer to polar. I like this better. I see the same coefficient in both cases. What angle should I be thinking of?
45.
45.
45.
Isn't it 2 and square root of 2?
Yep.
Wait,
Yep.
Alba, stop being fast.
All right.
Can I
Alba
pull out
comes
a
out.
4 out of that one?
Bingo. Yeah, so on the top one, I would change to 4. Well, not just 4.
No, it's 2.
4 is close. 4 would leave us with 1/2.
No, it's 2 and square root of 2.
Yeah. Minus 2. And 1/2 and 1/2 don't help us because they have to be a cosine and a sine. This is the cosine of 60 and the sine of 30, so that can't be one angle. So what you have to pull out is something that will leave you with root 2 over 2 on both. And what can you multiply by root 2 and wind up with,
8.
2.
well, by root 2 over 2 and
Root 2, right? Root 2
It's
times
2 root
is
2.
right, root 2 times Kathleen is halfway there.
2 root 2.
Yep, root 2 times root 2 would be 2. 2 over 1 would be 1. So we need to double it
In the table. So
and make it 2 root 2. The square root of 2
Yeah.
times the square root of 2 would be 2,
It's 2.
correct?
2 times
And 2
2
times 2,
equals
4 over 2,
Yep.
2.
4 over 2 is 2.
Yep.
I get it.
Okay, if you don't like that factoring trick, then I don't see a good way around drawing the triangle and realizing that you've gone 2 to the left. How about drawing the correct triangle? And realizing that you're gone 2 to the right and 2 down, and then using the Pythagorean theorem or your memory of special triangles to realize
5, 9 equals
that you're going to have a 2 root 2 hypotenuse. And,
Do that?
that's what you factor out. Yep,
That's what we're doing?
because
that's what you're doing.
So 2 root 2
You always factor out the hypotenuse.
is going to be your hypotenuse, and then that means that you're, yeah.
So this is,
That makes-
okay, so what quadrant is this in? 4? This is a
It's
45,
315.
very good, 45-degree reference angle in quadrant 4, so this is 2 root 2 cis 315. Okay? Now, remember I told you guys about thinking and processing earlier? There's a little bit of a reward for the thinkers, an Easter egg here. If you,
Root
now, what do
2.
you notice about this number and this complex number and this
Half.
complex
They're
number?
the same.
They're
half.
well,
Half.
this one's half of this one apparently, so it's going to be a proportionate triangle. And is it? They're both positive and both negative, so they're in the
Just
same
root 2.
quadrant.
Just with a different
Root 2.
hypotenuse?
Yep. And the hypotenuse will be
Is the
half
half of it.
because it's a proportionate triangle.
Well,
So
also,
this is root 2 cis
also
315.
because if you do root 2 times root 2, then it's 2 over 2, 1.
So it's root 2 cis 15. If you didn't see that by being able to compare these as proportionate triangles or as proportionate complex numbers, if you're already thinking that way, then you have to draw another triangle with the legs, with a positive leg of 1, and then a negative leg of 1, and then a root 2 hypotenuse. Yes, sir?
Can you erase that arrow?
Absolutely. It's probably left over from physics
People drawing on your board like
somewhere.
crazy.
That's right. Okay, so these are the two, but the question, the instructions were not to convert. The instructions were to
Divide.
divide. So z1 over z2 is going to be 2 root 2 over root 2 cis 315 minus 315.
350.
Wouldn't it be just 2?
Yep. So that's 2 cis 0. Whenever you have a cosine plus I sine that is either 0 or 180, you're back on the real number line. So you don't need the cis anymore. That's just 2. Now let's think a moment about this. What's the ratio between these two complex numbers?
Times 2.
Times 2. You're being asked to do division between two numbers, one of which is double the size of the other. Does this answer make sense?
Yeah.
Yeah.